because there are not too many. And then you can ask me, yeah? So there are 14 questions. I would say there is a real mix. Some questions are easier than others. So this is the first one. The first one, you could do it at the very beginning of year 12, probably. And you can do using logs or not using logs. I think when the base is the same in all of them, and you have to find solve the equation or find a relation between, in this case, x and y, is the easiest method probably is just to write everything in powers of 2 and just go from there, yeah? Janie, hello, we are just starting. So let's try to write, and if you do with me, it will be better. So let's try to write everything in powers of 2. So I can write 2 to the power of x, and then I know that 4 is 2 squared to the power of y is going to be 2 to the power of 2y. And then I'm going to bring this into the numerator. So 2 root 2 is 2 to the power of 3/2, yeah? Because you have 2 times 2 to the power of 1/2, you all know that. And when you add the exponent, you have 2 to the power of 3/2. So this is 3 to the power of 3/2. When it goes to the numerator, it just becomes negative. So what I have really is this. I can multiply the two powers that I have on the left. So I'm going to add the exponents. So I have 2 to the power of x plus 2y. More people come in. Hello. Is going to be equal to 2 to the power of minus 3/2, which means the exponents must be the same for both sides being the same. So I have that x plus 2y is going to be minus 3/2. Hello. And they just say, always check at the end if you are giving your answer in the way that they are telling you. In this case, it say express y as a function of x, which means we want y as the subject. Yeah, so let's going to make y the subject. I'm going to do 2y is going to be x go to the other side, so minus 3/2 minus x, and then I divide everything by 2. So I have that y is minus 3. I can just divide each of them. I think it makes sense. So minus 3/2 divided by 2 is minus 3/4, and minus x divided by 2 is minus x over 2. If you see I make a mistake, please tell me, yeah, because I make mistakes like everyone else. So if you see something like a sign that is wrong or something that doesn't look correct, please ask me or tell me. So this is the first one. I have actually the answers, just in case, the mark scheme. Yeah, so this is correct, yeah? Any question? Or everyone is good with this question? There are other ways of doing it, so you can take logs as well. I think it's just faster this way, but maybe you think it's faster taking logs. Next question. This one is a bit strange, I would say. So please try to read it. I give you like a minute to read it. You have the speed of a small jet aircraft was measured every 5 seconds, starting from the time it turned onto a runway until the time when it left the ground. So the results are given in this table. Time is in seconds, speed in meters per second. So this is the time that they say every 5 seconds, and this is the speed. Yeah. If you check these values, you see that it's not linear, for example. It's easy to see that it's not linear. It's not quadratic either, because here you have the same value, and suddenly it goes much faster. It looks like an exponential, maybe for the numbers. And they say, using this information, estimate the length of the runway you expect the jet to take off. I know I'm going to mix it with mechanics because I think it's going to make sense for you. If we try to represent this as a graph, the speed in the vertical axis and the time in the horizontal axis. So if we represent the speed here, and the horizontal axis, we represent the time, we have intervals of 5 seconds, so 5, 10, 15, 20, 25, yeah, and that's it. Then to something like 5, you're going to see, if you represent this, that this goes doing something like this, yeah, so some kind of exponential function. If you remember from mechanics, when you want to find the distance or the displacement, when you have the graph, velocity time graph, the distance or the displacement is going to be the area under the graph. Remember that? So this is what they are trying us to do. If you find the area, you're going to have the distance. They say estimate, yeah? So we don't have the function. If we don't have the function, we cannot find the exact area, but we have a method to do these kind of questions. We can approximate that area using, for example, trapeziums, yeah? So think that you have learned how to approximate the area under a curve, so an integral, using the trapezium rule. So this is an application of that. So you can think that you are finding the area of these trapeziums here, and that would be a fair approximation of the distance. Yeah, so you're doing something like that. We have a formula for the trapezium rule, so I wouldn't bother to find each of the areas. I would just use the formula, but you can find the areas either way because you have all the y's. Yeah, the area, the trapezium rule formula is in the formula booklet, and it says that you can approximate that area, or the area of the trapeziums is going to be 1/2 multiplied by the width of this interval, that must be the same, and in this case is the same, so times 5. And then you multiply, you open a bracket, and you have the first y just alone. So the first y is 2. And then you multiply 2 by all of the other y's, except the last one. So 2, 5, plus 10, plus 18, plus 28. And out of the bracket, you have the last y. Yeah, this is the trapezium rule. I can show you the formula if you need. Let me show you. So this is the formula booklet. And where you have different integration, you have the trapezium rule. Yeah, so it's 1/2 the width of the interval, the first y and the last y without the 2, and then 2 times all of the other y's. And that's what I'm just applying. Yeah, get the calculator and find the value. I think that's the best way of doing it, using the trapezium rule. So if you do that, I think I have the value. It's going to be 415 meters. Yeah. So this is going to be 415 meters. Using both things, the idea that the area under the velocity time graph is the distance, because we know that from mechanics, and the trapezium rule to find that area when we don't know the curve, but we know the y coordinates. Does it make sense? It's kind of a strange question, isn't it? Remember, every time you have units, give your answers with units. So in this case, we know the speed is in meters per second, which means the distance is going to be in meters. Yeah, that's why I wrote the meters. If you have any question, please ask me. Yeah, stop me and ask me. B, it says, given that the jet accelerated smoothly in these 25 seconds, so which means this is really a curve, yeah, smooth, explain whether your answer to part A is an underestimate or an overestimate for the length of runway. And this is a common question every time you apply the trapezium rule. So if you zoom into the graph, you're going to have something like your curvy graph doing this for each of the sections, and then your trapezium rule joining these y coordinates. Yeah? So you are doing something like this, which means if you are able to find the actual area, it would be under this curve. Yeah? If you have the equation of the curve, it would be the area under the curve. If you are approximating by the trapeziums, you are really adding this bit here. Yeah, just because you are doing straight lines instead of the curve, the real curve. So your approximation is going to be an overestimate. Yeah, you are adding that pink thing. So it's an overestimate. And you can say it's because the curve is convex. Yeah, so that's the shape, because the curve is convex. I think if you do, I don't know, kind of drawing, it will be super, super clear. Yeah, but this 1 mark. So they are asking just explain if it's underestimate or an overestimate. Yeah, as long as you see it, is more or less clear. Is it the question? Is the question clear? Everyone? Okay, good. Please ask if no. Question 3. Question 3, we have sector they say sector AOB of a circle, center A, radius 5, angle 40 degrees. The attempt of a student to find the area of the sector is shown below. So area of the sector is 1/2 r squared theta, 1/2 r is 5, the angle is 40 degrees, and the area is this one. Yeah? I guess you are already saying that they are asking you about the mistake. Explain the error made by the student. So you know that this formula is when the angle is in radians. Remember? So for this formula to work, is the angle must be in radians, and we have the angle in degrees. So that's why that's the error. Yeah. So he's using, or the student is using a formula. Student, I'm not going to dedicate too much time to write, but in the exam, I would recommend you to write things as clear as you can. The student is using formula of the sector area or area of a sector in radians. And we have degrees, yeah? So radians, and we have degrees. This is just one mark, so degrees. Write out a correct solution. So either way, you can change your degrees into radians and then use that formula, or keep the degrees and use the formula for the degrees. So remember the area of a sector, when we have degrees, is going to be the circle area and just the proportion of that sector. Yeah, so the sector have a whole circle around. So what we are doing is the area of the whole circle and then doing the proportion of this angle over the 360. Yeah. So the area of the whole circle is going to be pi r squared, but now we just want that portion, which is 40 degrees out of the 360. Yeah, we can find the area of a sector in degrees that way, finding the proportion. And this is, I'm not sure if I have the number. Yeah, I have the number. Think that this is, the radius is 5, so I have pi 5 squared times 1/9. Yeah, and this is 25 pi over 9. And if you want to evaluate with the calculator, you get 8.72 to 2 decimal places. These are centimeters. So the area is going to be in centimeters squared. I will write it. Yeah, don't lose marks for not writing units. It's really a shame. So, and I would add 2 decimal places. Yeah, always when you round, they don't ask you to round to anything or to give an exact solution. So it's really up to you how you write the answer. But if you round, say what you have rounded. Yeah, this question was easy. No? Any question about this one? No? Move on into the next one. Okay. Next one. Perfect. This one is a parametric equation question, and it's a curious question. It's not the typical that you have to find the Cartesian equation or a tangent or differentiate or something like that. Let's see. So you have card C1. So this oval, this has these parametric equations. T is between 0 and 2 pi, and meets the circle C2 with this equation. So we have the circle here at 4 distinct points. Yeah, so are going to be these 4 points. There are 4 points of intersection. Given that one of these points S lies in the 4th quadrant, find the Cartesian coordinates of S. We don't have to find the Cartesian equation of the oval. We need to find the coordinates of this point, but not the parameter. We need to find the x and y. When they say the Cartesian coordinates of S, that's what they mean, the x and the y. Yeah. So the way of finding the intersection between two curves, remember, is solving simultaneous equations. Yeah. So what we are trying to do is to find 4 points that satisfy both equations, the parametrics of the oval and the Cartesian of the circle. So the way of doing that is solving these 3 equations together. I think if you think a tiny bit, you will see very quickly that you can substitute the x here, substitute the y here, and then you have just an equation with the parameter. Because otherwise, there are different ways of solving simultaneous equations. But in this case, we want the parameter, because when we have the parameter, we can find the x and y. So that's what we can do easily, to have one equation only with the parameter. Yeah. So I'm going to do that. I'm going to substitute in my circle the parametric equations of C1, of the oval. So I have 10 cos t squared plus 4 root 2 sine t squared is 66. So squaring these terms, I have 100 cos squared plus, you can do this with a calculator if you want, but it's 4 squared times 2, which is 32. 32 sine squared t equals 66. And please don't think about every time you have sine and cos, not necessarily you're going to divide by cos to have tan. If you divide cos here, you make a mess. Because, yeah, this one is going to be simplified, and this one is going to be tan squared, but this one you're going to have the something divided by cos, so you're going to introduce the sec, so it doesn't make sense. You have the squares, which if is going to be very helpful to substitute one in terms of the other. So we can write, instead of cos squared, 1 minus sine squared, or instead of sine squared, 1 minus cos squared. It doesn't matter, yeah? So I'm going to do 100, 1 minus sine squared. Maybe it was the other way around better. And I have everything in sine squared. So I have 100, just expanding the bracket, minus 100 sine squared t plus 32 sine squared t equals 66. So I'm going to put all my numbers in one side. 100 minus 66 is 34, no? And then I have 100 minus 32 is 68, no? Please, if I do something wrong, tell me. Which means that sine squared t, just dividing by 68 both sides, is 34 over 68, which is 1/2, yeah? So we are very close to find the parameter. I'm just solving the trigonometric equation. So sine t could be 1/2, or sine t, root of 1/2, or sine t could be minus root of 1/2. Either, yeah? And if I use the solutions in all my values of the parameter, I will be able to find the 4 solutions. But they are asking me for this particular solution. This solution in the 4th quadrant, so I'm going to find the value. Let me do this one with the calculator. So if I do this with the calculator, in radians, because they say the interval for the parameter is 0 to pi, which means we are working in radians, I have minus pi quarters. So t is going to be pi quarters. And in this case, it will be minus pi quarters. T is minus pi quarters. So now I have to think which one, if any of these two, or maybe the next solutions, is going to give me the point in the 4th quadrant. So in the 4th quadrant, the x is going to be positive and the y is going to be negative. Yeah? And the points are given by my parametric equations. So the cos must be positive and the sine must be negative. So you have to think which one is going to give you positive cos and negative sine. Yeah? If you're a bit confused, use the calculator, because you have the calculator in your exam. So just try the values. So you try the pi quarters and then you try the minus pi quarters, or you find the next solution and you try the number. Yeah? But the one that is going to give us positive cos and negative sine is the minus pi quarters. Yeah? So when t is minus pi quarters, if you substitute the x and the y, you have that the x is going to be 10 cos minus pi quarters, which is 5 root 2. So this one is the x, and the y should be negative. So the y is just from here. I'm just substituting here 4 root 2 sine t. So 4 root 2 sine of minus pi quarters. Minus 4, which is what it should be. So the point S, and I would write the coordinates of S properly, is going to be, so S is 5 root 2 minus 4. Yeah? And this is it. We don't have to do anything else. So it's a curious parametric equation question. Yeah? And it requires a bit of thinking when you choose the actual value of the parameter. Does it make sense? And if you are not maybe able to see straight away which value of t use, think that you can use the calculator. So find what x and y are with root 1/2 and what with root 1/2, no, with pi quarters and with minus pi quarters. Yeah, and then you will see that the point is not in the quadrant that you want. That's why. Okay, I saw lots of thumbs up, so more questions. This one is an unfrequent question. So it's something that appears, I think I have seen it once in AQA, once in Edexcel in the last 5-6 years, no, since the specification changed. But the thing is, some of you have told me that in the new textbook, you have some examples that you didn't have before in Edexcel. So I would just keep that in your head because maybe this year they want to ask it. That's why it's in the textbook. So you have, you are able to approximate a sum of little vertical bars, the areas of that bars, by an integral. So it's an approximation of the integral under a curve. So what you need to know is, they say, you have a sketch of this curve, the root x. Point px lies on the curve, so I have a point x, y. The rectangle, so this one, the rectangle that they have shaded is, the area is this one. This limit is just the integral, and you need to remember for these questions, it's just 3 marks, so it's not the end of the world if you don't do this question, but it's quite simple. So you don't have to do the limit. You need to remember that this limit is really an integral. So root x delta x is going to be the integral definite between these two values, so 4 and 9, of the function that you have, which is root x, dx. You just need to remember this, and the questions are going to be easy. So I told you I haven't seen many questions because they haven't asked this a lot, but the integral is quite simple. So we are going to integrate x to the power of 1/2. Yeah, remember I can write this as x to the power of 1/2, which is more convenient to integrate. So I have x to the power of 1 more, so 1/2 plus 1, 3/2, divided by 3/2. So I can write the 3 and the 2 here, or the 2 at the front, yeah, because it goes up when I divide. Then I substitute by 4 and 9. So this is going to be, when I substitute by 9, I have root, you can do it with the calculator. Root 9 is 3, 3 cubed divided by 3 squared is 3 squared, which is 9 times 2, 18. So this is f of 9, and then the same with the 4. So with the 4, I have root 4, which is 2, cubed, which is 8, times 2, which is 16/3. Yeah? 16/3, and then this is 38/3. No? 38/3. And the key thing is that you remember that the limit of a function, and that would be something like the limit of any function, the x of the sum, sorry, the sum between x equals a and b of a function delta x is going to be the integral between those values, yeah? Between a and b of the function dx. That's what you have to remember. It's not difficult, and if you remember that this is an integral, very quickly you are going to remember that these are the limits and you have to integrate that. So it's not too complicated. Is the question okay as well? Any question? No? Move on into the next one. Perfect. Number 6. So we have a functions question. We have the sketch of the graph of y equals gx. Gx is this function here, which is a quadratic when x is smaller or equal than 2. So up to here. So this should be 2. Yeah. And then is a straight line, which is this one, when x is greater than 2. So it's one of those functions that they defined in 2 different ways. Find the value of g0. Remember when I have fg or something, so just if I have if I have fg of 3, what I'm doing is f of g of 3. So I always do the closest to the number first. I find g3, it will be a number, and then I do f of that number. So I'm doing the same if I have the same function twice. I'm going to do g0 first, and that will be a number, and then I do g of that number. Yeah. So let's going to try that. With these functions that are split depending on the value of x, you have to be careful of which one you choose. Yeah. If we do g0, we need to pick this one because x is smaller or equal than 2. So I'm going to do g0. So for a, I do g0 is going to be 0 minus 2 is minus 2, squared is 4, plus 1 is 5. Yeah. So I would write some working outs so it's clear what you have done. Yeah. 2 plus 1, which is 5. And now you do g of that. So now we do g of 5. But now careful because it's not the same function. Now 5 is greater than 5. So we have to use this function here. So our g of 5 is going to be 4 times 5 minus 7, which is 13. Oh? So g0 is 13. Yeah? Easy, quite straightforward. Is 2 marks, is going to be 1 per page. Then find all the values of x for which gx is greater than 28. Greater than 28. They have given you a graph. I think the graphs in general help us to see what we are doing. So gx is this function. This function is going to be greater than 28 when it's above a line that is y equal 28. Yeah, so imagine this is a horizontal line that is 28. Above that graph, my function gx is going to be greater than 28. So that means, and it's very easy to see in the graph, that we are going to find like 2 branches. Yeah, so I'm going to have 2 sets of values where my function is going to be greater than 28. So I will have to find them separately because I have 2 equations for g. So that's what I'm doing. So I'm going to see when this quadratic is greater than 28, and then I'm going to see when this line is greater than 28. Yeah. So this quadratic greater than 28, or at least I'm going to make equal to 28, and then I'm going to have the values on the left to that. Yeah. So let's going to find this point. It's going to help us to find this point. I'm going to make x minus 2 squared. So for b, I'm going to do x minus 2 squared plus 1. Plus 1 equal to 28. So I have, yeah, I'm not going to expand the bracket because it's easier. So 28 minus 1, 27, which means x plus x minus 2 is going to be plus or minus root 27. So x is going to be 2 plus or minus root 27. We have 2 options because it's a quadratic. So I am using just this bit of the quadratic, but my quadratic will cut this line in another point here. But this x is positive, this x is negative, so I'm interested in this one. So I'm going to pick the negative one, which is the 2 minus root 27, which is negative. Yeah. So this point here, the x is 2 minus root 27, which means every value to the left of that value of x, my function gx is going to be greater than 28. Can everyone see that? Because sometimes it's a bit confusing. Did you understand? If not, I can repeat it. Yeah, but from this point to the left, all my values of g are above 28. So one part of my solution is going to be x smaller than this value. Yeah, so one part, it will be x smaller than 2 minus root 27. And I don't include the equal here because they ask me just greater, not greater or equal. If they include the equal, I will include the equal. And then the other branch, I'm going to find this point. Yeah. So this point is this line equal to 28. So it's even easier. So for the second part, I'm going to do I forgot the line. For x minus 7 equal to 28, which means for x equal to 21, so x is equal to 21 fourths. And this is this value here, 21 fourths. So my gx is going to be above 28 on the right of that value. Yeah, so any value greater than 21 over 4 is going to be above. So this is x greater than 21 over 4. So if you want to give your full answer, it will be x smaller than 2 minus root 27. Ethan, question?
Yeah, you're not adding 7 instead of minusing it, so it'd be 35, not 21.
Oh, okay. And Ruth, you were going to say the same. Thank you. Yeah. So I have 28 plus 7 instead of minus 7, so it's 35, which means x is going to be 35 over 4. So this value here is 35 over 4. So my x must be greater than 35 over 4. If I combine both solutions together, I have to say something like x is smaller than 2 minus root 27, or x is greater than 35 over 4. They don't ask me use set notation because they say only find all the values of x, which that happens. Yeah. But if they ask me to write same notation, remember I'm just going to add the x column, the curly brackets, and instead of or, I'm going to be more professional. I'm going to write union because union is this or that. Yeah. And again, the column, the x column, and the fancy brackets. Yeah. That would be the best way of writing the answer. If they don't ask you to write insert notation, it's fine if you just write with as we wrote first. Yeah. It's okay. I just to remind you in case they ask you. All good so far? The function h, so now we have another function, is this one here when x is smaller or equal than 2. So it's really this part of the function is, yeah, just this bit. It says explain why h has an inverse, but g does not. I'm going to remind you, do you remember what the inverse function is? So if I have a set of values and I do f of those values, I have the values here. F minus 1 is giving me the initial values again, yeah, the input. For a function to have inverse, do you remember what does have to happen? It needs to be 1 to 1. So remember, there are transformations that are 1 to many, others that are many to 1, and others that are 1 to 1. So for a function to have inverse, it has to be 1 to 1. This function here, dx, is many to 1. So I have different values of x that give me the same value of y. Yeah, so these values of x and these values of x gives me the same y. So I have values, different values of x that give me the same value of y. So it's not one-to-one. That's why there has no inverse. While this one is one-to-one function. It's not defined when when x is greater than 2, but it doesn't matter. Has inverse in the domain. Yeah. So that's the reason, and that's what you should explain. So H has inverse, but that G does not. So H has inverse because it's a one-to-one function. It's a one-to-one function, but Gx is many to one. Yeah, so many to one. Two values of x are giving me the same value of y. Yeah. And the last thing they ask, and that's something that you have to remember. I suppose it's difficult to give much thought of that. Solve this equation. This equation, remember we have learned how to find the inverse of a function. So usually you change, or you make the x the subject and then change the y by the x at the end, or you change the y and the x and you make y the subject. So we have a method to find h minus 1. If you try to make x the subject here, it's crazy because you have a quadratic and you're not going to use the quadratic formula to find the function. It could be very, very complicated. There is a very, very simple way, and think that they are not asking you to find the function. They are not asking you find h minus 1 of x. They are just asking you to find the value of x that gives you h minus 1 equal minus a half. So I hope you're thinking the easiest way of doing that, which is just if h minus 1 of x is minus a half, that means that h of a minus a half is x. Yeah. So what we are doing is I have a function h and a function h minus 1. So h minus 1 of x is minus a half. Yeah, h minus 1 of x is minus a half. That means that x is h of minus a half. So I'm just doing that. Yeah. So x is going to be, x is going to be h of minus a half. I'm just doing that kind of forward, backward. So h of minus a half. It's just going to substitute here. So minus a half minus 2 squared plus 1. So this is going to be equal to minus a half minus 2, minus 2 squared plus 1. Minus 2 squared plus 1, which is minus 5 halves squared plus 1. I don't want to do this wrong. 29 quarters. Yeah, 29 quarters, no? 29 quarters. That's the value. They don't ask me to round or to give in any particular way. I could just leave it. It's a nice number like this. Any question? No? All good with this one? Okay, so then I will move on. It's clear this question here. Look, it's 3 marks, but I think it's because not just finding h of minus a half is quite easy, but I think it's because they are evaluating if you understand what h minus 1 is really. Yeah, so you have to understand. And trying to find h minus 1 here, it would be quite complicated. And that's why they don't ask you. If not, sometimes they ask you to find h minus 1 and then they ask you something else. Yeah. Okay, more. Question 7. Small factory makes bars of soap on any day. The total cost of the factory, y, of making x bar of soap is modeled to be the sum of 2 separate elements, which makes probably sense. Fixed cost and a cost that is proportional to the number of bars of soap that are made that day. Which, as I say, I think it sounds quite normal. Write down a general equation linking y with x for this model. So y is the cost of the factory. So it's the total cost of the factory. Y is the cost. And x is the number of bars. Yeah, so an x is number of bars. And they say the total cost, so the y, is modeled to be the sum of two separate elements, a fixed cost, let's say A, and the cost that is proportional to the number of bars they are making. So another constant times the number of bars that they are making. Yeah, it's a straight line. You can see that. So this is the only thing that they're asking you here. So come back. The bars of soap are sold for £2 each. So that's going to say £2 each. On a day where 800 bars of soap are made and sold, the factory makes a profit. Be careful because we haven't mentioned profit so far. It was cost and number of bars of £500. On a day where 300 bars are made and sold, the factory makes a loss of £80. Using the above information, we have to find the line that we just wrote here. Yeah, so we have to find the A and the B. So let's see if we are able to write some information. So the profit is going to be the sales minus the cost, yeah, of anything. You see how much money you get and you subtract the money that you lose because you are producing the thing. In this case, so the first one, if I want to think of the first one says the profit is 500. So the profit 500 is going to be the sales, so all the money that comes in, and think that they are selling 800 bars at £2 each. Yeah, so that day they are getting £1,600. So that's the all the sales, 1,600 minus the cost. And the cost is this one here. This is the cost. Yeah, so we can say that the cost, I think, minus the cost, minus y. So from here, I know that y is going to be 1,600 minus 500 is 1,100. But I have an equation for that, which is this one. It's going to be A plus B, and I produce 800 bars, so this is times by 100. So I have one equation here that relates A and B. And I think you are guessing already that we are going to have simultaneous equations because we have two unknowns to find, A and B, and we have two lines of information, this one and this one. Yeah. So that's going to see the same, to do the same with this one. So the profit is not profit. Profit in this case is loss, but we can say that the profit is minus 80. Yeah. So if we use the same, the profit in this case is minus 80. The sales is, I have 300 bars, £2 each is 600, so they make 600 minus y, which means that y is minus. No, I'm doing wrong. Y is 600 plus 80, sorry, 680. Yeah. And this is going to be equal to A plus B times the 300 bars that they are producing. Second equation, two unknowns, two equations. I'm going to solve it, and I'm going to find those constants that I'm trying to find. Yeah. How you solve simultaneous equations is up to you, but solve working out, because it's something that you can solve with the calculator. If you don't solve working out and you suddenly write your A and your B first, they are giving you the answers, yeah, which could mean that you just wrote it down without bothering in solving the equation. And second, you could be solving it with the calculator, which is what I would do, to be honest, but always show the working out. So solve with the calculator to be sure what you're doing, but then show the working out. So I could, for example, subtract them to get rid out of the A. So I have 1,100 minus, 100 minus 680. So I have 420, just doing 1 minus 2. 1 minus 2. I have 420 is A minus A are gone, and I have 500B, which means that B is 420 divided by 500, which is the 0.84 that we needed. So that's good. And then from A there, I can get A. So for example, for number 1, A is going to be 1,100 minus 800 times B. And then I get the other value that I need to find. I'm just going to do it just in case. 428, no? Yeah. So those are the two values that we needed. The A and the B, yeah? All good so far? Okay. C. With reference to the model, interpret the significance of the value of 0.84 in the equation. Again, typical question when you have a straight line. The 0.84 is the gradient, and the gradient is telling me how much the y changed. So remember, gradient is changing y divided by change in x. You know that. But when you have a context for the line and a wordy question like this one, a modeling question, you have to say something more specific to the question. So the 0.84 is how much the cost increase when you increase 1 unit, the x. The x is the number of bars. So that means that every bar, every extra bar that you make, the cost increase by 0.84, which just means that each bar that you produce costs 84 pence. Yeah. So it's there are a few ways of saying, say with your own words, that the 0.84 means the price of producing a bar, yeah, which is 0.84 pounds. And I would write something like that. So is the price of producing one bar, or the cost, yeah, it's the cost of producing one bar of soap, yeah. So each bar is 0.84 pounds. Does it make sense? Is confusing? So remember, gradient is change of y divided by change of x. In this case, the change in y is the cost, and the x is the number of bars. So every time this changes 1 unit, this one is going to increase by 0.84. So that's the price of 1 unit of soap. Yeah, that's what it means. Assuming that each bar of soap is sold on the day is made, find the least number of bars of soap that must be made on any given day for the factory to make a profit that day. To make a profit, we want the sales greater than the cost. Yeah, and now we have a model for the cost, and we know the sales because it's 2 pounds multiplied by the number of bars. So to have a profit, we need that the sales are greater than the cost. Yeah, the sales are 2 pounds multiplied by the number of bars. They're asking us the number of bars. This must be greater than the cost, and the cost is that equation that we have there. So the 0.84 times x plus 428. Yeah, 428. I'm just going to solve this inequality. So I have 2x minus 0.84 is 1.16. X must be greater than 428. So x must be greater than 428 divided by 1.16. X must be greater than 368.965, something like that. You have to round, and you have to round to what it makes sense. So remember, when you're trying to find an amount of something, not always we are rounding to the nearest number. Sometimes we are rounding to what it makes sense. So I need to make at least this number of bars to have a profit, which means I need to round always up. In this case, I don't think you would make a mistake because you would round up anyway. But if this is 368.2, don't round down, because if you round down, so imagine is 368.2. You could say, oh, 368. But with 368, you're going to have profit. Yeah, that's what you will need to round to where it makes sense, even if it's not what you would round to, yeah, in normal circumstances. So it's not the case in this question. So you could say that you need 368, 69. Sorry, and then I do something else. Bars to have a profit. Yeah. Tell me, how is the question? It's okay. You have any question? No? All good? Move on into the next one? Okay, well done. Question 7. So you have a series and sequences, or a series question. You have to find the value of this sum. This is a geometric series because you are multiplying but this common ratio, and you are adding infinite terms. You have a formula in the formula booklet to add infinite terms of a series, geometric series, where the ratio is smaller than 1. Yeah, don't forget that you have that formula in the formula booklet. I can show you. Where is it? Is here. Yeah, so for geometric series, the sum of infinite values is a divided by 1 over a divided by 1 minus r. This one, I think it's going to help you a bit to think what you are adding. So when r is 4, it's going to be your first term. Yeah, so when r is 4, your first term, this is like, so the first term, usually we call it a, is going to be when r is 4. So it's going to be 20 times 1/2 to the power 4. That's the first term. So I have 20 divided by 2 to the power 4, which is 5/4. So that's my first term, and that's what I need in the formula. So the formula, remember, said is going to be a, which is the first term, divided by 1 minus r, and r is the common ratio. So r is 1/2. So this is going to be 5/4 divided by 1 minus 1/2. So divided by 2 is 5/2, no? 2.5. 2.5. That's the sum of infinite terms of that series. Just applying the formula has nothing complicated. Yeah. First term is when r is 4, not when r is 0 or 1, is when r is 4, because it's when I'm starting to add my terms. The second one, I hope you have a minute to think about it while I'm copying the question. So please think what you would do with that one, because it's a curious question. And I think it's difficult to do. So you have to show that this sum is going to be equal to 2. In this type of questions, I think it's very helpful to write a few terms, because then is when you start to see patterns and if you can do something. If not, trying to work with this expression alone is quite hard. Yeah. So if we write a few terms, when n is 1, I will have log to the base 5, 1 plus 2, 3 divided by 2. Yeah. Then the next one will be log to the base 5. When n is 2, I will have 4 and 3. The next one will be log 5, 5, and 4. Up to the last term would be log 5. 48 plus 2 is 50, and 48 plus 1, 49. Now you have an addition of logs, and you know properties of the logs. So I think now it's going to be easier to add these logs, because when you are adding logs, you can have log of the product of the numbers. Yeah. So this, using the properties of the logs, is log of 3/2 times 4/3 times 5/4 times up to 50 over 49. And I think you are seeing now what happens. So we are going to cancel this one with this one, this one with this one, this one with the next. And we are going to cancel this one with the 49 that we have here. Yeah. So at the end, what we have is quite simple. It's just log to the base 5 of 50 divided by 2, which is log to the base 5 of 25. And log to the base 5 of 25 is just 2. And if you don't remember or you are not able to think, just do it with the calculator, but it's 2. That's what we have to prove. Yeah, it's quite a clever question. But when you are working with series and you have to add terms, I think sometimes it's difficult to understand what you are adding unless you start to write a few values. When you start to write a few values, you will see what you are adding, or sometimes you discover that it's an arithmetic sequence and you haven't even realized. Yeah, so I think it's hard. Again, how is this question? Is clear? No questions? You're super quiet. Okay, next one. Let's do one more. This one is one of those logarithms questions when you have the straight line and the change of variable and the coding and all that. So you have a research engineer is testing the effectiveness of the braking system of a car when it's driven in wet conditions. The engineer measures and records the braking distance, d, in meters when the brakes applied from a speed of v kilometers per hour, and graphs of d against v and log d against log v have were plot, and the results are shown here. Yeah. Remember that sometimes, mainly when we have the scatter graphs, we have a connection between two variables that is not linear, but we don't know what it is. If we code the values into log, or into just log and x, sometimes we get something that is more a straight line. Yeah, we know how to find a line of regression between two variables. There are formulae. You don't need to learn them. You don't need to use them anymore, but there are formulae that can give you, when you have the points, the straight line, yeah, the line of regression, which means if you don't know what is the connection between these two, but you know what the connection is between these two, you can undo your change and then have a formula for this one. And that's what we do with these questions. So it says, explain how figure 6 would lead the engineer to believe that the braking distance should be modeled with this formula. This formula is this one here. It's giving you the relationship between D and V. And what we know is there is a linear relationship between the logs. So to do these questions, there are a couple of ways of doing. Or you start with the equation of the line between log and log, and then you use the properties of the logs to have this formula. Or you start with this formula, you take logs, and you see that it's a line. Either way, it doesn't matter, yeah? So you can do either. I think it's easier probably to take logs here. So let's go into take logs. I have, wait, and they ask us to find k, yeah? We are going to see how we find that. So I have that, I want to see that this is possible. So I'm taking logs, I have log d is going to be log a, well, just taking logs. I'm not going to skip steps. Yeah, using the properties of the logs, I can write that log d is going to be log k plus log b to the power of n. And then again, using the properties of the logs, this n can go to the front. Yeah, so I can write that log d, I'm going to do here, log d is log k plus n log b. And if you realize, this looks quite linear because we have a variable that is this one in the vertical axis. Yeah, so this is working as a y. Yeah, so this is our kind of y. Then we have a number. Log k is a constant. This is going to be our y-intercept. Yeah, and then we have a number and my variable in the x-axis, the log b. So this is our x. So this is our x, which means this is our gradient. Yeah, so that's how they are behaving. Does it make sense? So taking logs in that expression, we see that it's behaving like a straight line. So is either way, or you start with the straight line and then you work your way to half the expression, or you start with the expression, the exponential expression, and then you find this one. So this is how you see that one takes you to the other. How we find this k? This k is, you don't know k, but you know log k, because we say is the y-intercept of this line, and the y-intercept is given. So the y-intercept is -177. So I know that log k to the base 10 is -1.77. So that means that k is 10 to the power of -177. You can check with the calculator, but we are going to get the value that they say. So 10 to the power of, 10 to the power of -177 is 0.01698. That rounded is 0.017. Yeah. Hello, and have people joining now. We are doing question 9, so we have done a few questions already. But I'm recording it, so I will send you the recording for the questions that you missed. So this is the first part. And as I say, you can start with the formula, take logs, and see that you get a straight line, or you can start with the equation of the straight line, work with the properties of the logs, and eliminate the logs to have an expression between just A and D. Yeah. Using the information given in figure 5 with k 0.017, so in this one, not in this one, find a complete equation for the model given the value of n in 3 significant figures. So I know it's confusing because you have lots of letters, yeah, and they are not x and y, but this is a variable, and this is a variable. Those are your x and y, while the n and the k are constants that don't change. So when they ask us to find the model, what they are asking us is to find the constant, because the variables change all the time. So we found k already. Now we are trying to find n. And they say, use this graph. What do we know in that graph? 1 point. If we know 1 point, we substitute the point, and then we find n. Yeah? So the b is 30, and the d is 20. Yeah, so if I substitute in the graph the b by 30, so I'm going to do that. This is my, so I have that d is k, which is 0.017, b to the power of n. D is going to be, is 30 or 20? 20. I don't want to get it wrong. 0.017. So just substituting in the 30/20 times b, which is 30 to the power of n, I will find n. How? I'm going to do 20 divided by 0.017 is going to be equal to 30 to the power of n. And that means you can solve this in a few ways. So you have your n in the exponent, and every time you have the x n in the exponent, you can take logs. You can take logs in any base, really. But I think the most helpful in this case is just take logs in base 30 to the base 30, because with the calculator, it doesn't matter. So if you take logs to the base 30, you have log to the base 30 of 20 over 0.017 is log to the base 30 of 30 to the power of n. You know that this one is going to be n, or this is the exponent when the base and the base are the same. So that means that n straight away is log to the base 30 of this value. Yeah. If you take logs or in any other base, you will get the same answer. Yeah. But you will have one more number there. So with the calculator, we just do log to the base 30 of 20 divided 0.017, and if I've done correctly, I get 2.07876. They say to round to something, I think. 3 significant figures. Yeah, so please check how they ask you always. Don't give wrong answers. Don't miss marks for that. 2.08, no, 2, 3 significant figures. and this speed. So the model is going to be d equal to 0.017 v to the power of 207. And it's quite typical that once you have the model, they ask you something. So they ask you, or to find the distance that it takes to brake when you know the velocity, or they ask you the velocity when you know the distance that it takes to brake. It's just substituting in the formula. Yeah, but they usually like asking you something. So let's see what they ask. Son is driving the car at 60 kilometers per hour, so we know V. In wet conditions, when he notices a large puddle in the road 100 meters ahead, it takes him 0.8 seconds to react before applying the brakes. Use your formula to find out if he will be able to stop before reaching the puddle. So we know the velocity. If we know the velocity, we are able to find the distance that it takes for him to brake since he applies the brakes. Yeah, be careful because we have an extra here of 0.8 seconds that he is doing nothing. Yeah, just reacting. And we will have to count that. But let's going to see the distance that he needs to brake when he starts at 60 kilometers per hour. And they check that the units are the ones in the formula. So in the formula, V is in kilometers per hour, and D is going to be meters. Yeah. So let's going to see how long it takes for him to brake, how the distance that he's moving. So D is going to be 0.017 times 60 kilometers per hour, 2.8. So he needs 0.017 times 60 to the power of 208. 84.918 meters. Yeah, but that is since he applies the brakes until the car stops. There are 0.8 seconds where he's still traveling at 60 kilometers per hour. So we need to know how many meters he moves in those 0.8 seconds. So that second distance, let's say D1, D2, is going to be, I have the velocity. So the distance is going to be the velocity times the time. Velocity, so velocity times the time, is going to be 60 kilometers per hour times 0.8 seconds. But you have to be careful with the units. So I'm going to write the units. So I have 60 kilometers per hour, and then I have 0.8 seconds, and I want the meters. So what I'm going to do is I'm going to divide by 3,600 to have the seconds in hours, or the hours in the denominator in seconds. So I'm going to divide by 3,600, and I'm going to multiply by 1,000 to have meters. Yeah, so these kilometers into meters, and this in seconds, all in seconds. And I have 60 times 0.8. 13.3 recurring meters. Yeah. So the time that the distance that takes him to stop is going to be the total distance is going to be D1 by D2. Distance is going to be D1 by plus D2. So the time that it takes for him to react, he moves 30.3 meters more, and then when he brakes, he needs 84 meters more to brake. Yeah, 84.918. This is 98.25. 98.25 meters, which means he doesn't reach the paddle. The paddle, remember, was 100 meters ahead. And it says, find out if he will be able to stop it before reaching the paddle. So he will. Yeah. So write a conclusion, right? He will be able to stop before the paddle. He will be able to stop before the paddle. To stop before the paddle. Does it make sense? So this is, he will be able to stop. I would say every time they ask you to find a model with these exponential questions, you will have to use it. They are going to give you one of the variables or the other. Sometimes the question will be a bit more elaborated like this one, because you have to consider the first 0.8 seconds, but is it clear? Do you understand the question? Yes, more people. Okay, do you have questions? Please, if not, ask me, and I will go through any bit that you need again. Yeah. This is one of the difficult ones. I think these exponential and linear models are a bit complicated always. Well, we have a vectors question now. So you have figure 7 shows a sketch of triangle OAB. So OAB is this triangle here. Point C is such that OC is to OA. So what I have is another point here in this extension that OA is, I can do something like this. So C will be roughly here, and OC is to OA. Yeah. The point M is the midpoint of AB. So AB, I have a midpoint. I'm just drawing it because I think it's easier to see things when we draw them. Straight line through C and M cuts OB at point N. So I have another straight line here joining M and C and cuts this one at point N. That's already complicated. Given that OA is vector A, so this vector here is A, OB is B, so OB is this whole thing, so OB is going to be B. So we have those two vectors. Find CM, sorry, in terms of A and B. CM, so we are looking for this vector, and these vector questions, there is more than one way of doing them, because there are more than one way of going from one point to another. And sometimes one is easier than another. So if something becomes a bit too complicated, try another way. I would say from C to M, we can go this way, for example. Yeah, so we can do CA plus AM. So think that we are looking for this vector, CM. So we have to think another way of going from C to M using vectors that we know. So we can do CA plus AM. CA, this one and this one are the same vectors, but this is the other direction. So CA is minus A. I'm going to write the whole thing. So we can say that OCM, so for A, CM is going to be CA plus AM, we say, yeah? CA is minus A. CA is minus A. And then AM is half of AB. Yeah, because this is the midpoint, AB. And I can find AB because AB is B minus A. So I can go this way. Yeah, AB is B minus A. That's quite simple. So, and this is half. So AM is 1/2 of AB, and AB is B minus A. Yeah, and we can just put together the A's and the B. So I have minus A minus 1/2 of A is minus 3/2 of A plus 1/2 of B. Yeah, so this is the first one. And probably you can go from C to M in another way. I just think this is the simplest. Then another, B says, show that ON is this coefficient multiplied by A plus 1/2 of lambda multiplied by B. How can we do that? ON, we can use OC plus CN. OC is 2A, yeah? And CN, we just found this vector, and Cn is just going to be a scalar multiplied by this vector. That's what that lambda appears, yeah? So we are going to do that. So On is OC plus Cn. This question is a bit complicated too. When you see it, it's okay. If not, it takes some time to figure it out. So On is going to be OC plus Cn. OC is 2a. We know that, yeah? OC is 2a. They give it to us. And Cn is going to be a scalar multiplied by Cm. So a scalar multiplied by Cn. And we found Cn before. So it's this one. So this is going to be minus 3/2 A plus 1/2 B. And now we are going to rearrange for A and B. So for A, I have 2 minus 3/2 lambda. That is precisely what I have here. So that's what I wanted. So this is equal to 2 minus 3/2 of lambda multiplied by A. And then the B is going to be lambda 1/2 of B. That's what I need. Yeah. So plus 1/2 of lambda times B. And that's where it comes from. It comes from doing this vector plus this vector, and this vector is a scalar multiplied by this one. So every time you have one vector in the same direction, it's just different length, is going to be a scalar multiplied by the other vector. Yeah, you know that parallel vectors, the difference is just a scalar. It's one multiplied by a scalar. So that's what we are doing. More things. It says C, hence, so using this, prove that ON to MB is 2 to 1. ON to MB. ON to MB. So what we can do is to find lambda, because it's going to help us to know ON distance, yeah, and in terms of B. So let's going to find lambda. ON, ON is a parallel vector to B. Yeah, so we have written in terms of A and B that ON is parallel to B, which means really it shouldn't have a component. Yeah, it's going to be a scalar times B if it's parallel to B. So that means that this thing here must be 0 because it's only parallel to B. So if we make this equal to 0, we can find our lambda, and it's going to help us. So for C, I can say that as ON is parallel to B, really the A component is going to be 0. So the 2 minus 3/2 of lambda is going to be 0, which means 3/2 lambda is 2, which means lambda is 4/3. If lambda is 4/3, that means that ON is what is this component is 0, and then is 1/2 times lambda B is going to be 1/2 times 4/3 times B, which is 2/3 of B. And now it's quite simple. So this whole thing is B. This bit is 2/3 of B. Yeah, so can you see that? I have this length, and I just discovered that ON is 2/3 of the whole thing. So if I divide my thing in 3, so let's say here, yeah, so if I have 3 bits, ON is 2/3 of the whole thing, which means the ratio ON to MB is 2 to 1. Yeah, just because of that. So I hope you see it, because this question is a bit. So therefore, you can say that ratio ON to MB is 2 to 1. Yeah. Can you see this bit? Because it's not super obvious. Do you understand? Do you have any question? No? Okay. More. Perfect. More. Question 11. You have figure 8 shows a sketch of the curve C with this equation. Yeah, so x to the power of x. Why is x to the power of x when x is positive? First, find by firstly taking logarithms the x coordinate of the turning point of C. And it's 5 marks. Yeah? So coordinate of the turning point of C. To find the turning point, you know you're going to derivate and make that equal to 0. They give us a clue. Find firstly taking logarithms. Remember, in all the questions, or most of the questions, it doesn't matter what the base of the logarithm is. So you can take natural logs, or you can take logs in base 10. It doesn't matter. In this case, it's going to matter because I know how to differentiate natural logs, but you haven't known how to differentiate logs in other bases. So we are going to take ln, yeah? So if I have my curve and I take ln, I have, so for A, I have that y is x to the power of x. If I take ln, I have ln y is going to be ln x to the power of x. And they are asking me to take ln to use the properties, obviously. So I'm going to write that ln y is going to be x ln x. And now I'm going to differentiate to find the stationary point. If I have an expression like this one, where I cannot separate the y or the x easily, remember, you're going to use implicit differentiation because it's super powerful for expressions that are, the questions are, the x and the y are quite mixed. So if I differentiate implicitly, I have derivative of ln y is going to be 1 over y, and then I have to multiply the y by the x every time I differentiate the y in an implicit differentiation, yeah? And then I'm going to apply, for the second part, product rule. Derivative of the first one, 1 multiplied by the other, ln x, plus the first one, x, times derivative of ln x is 1 over x. So I have plus x times 1 over x. That can cancel and is 1. So what I have is that 1 over y dy by dx is ln x plus 1. And I'm going to make dy by dx the subject to be able to make it equal to 0 to find the stationary point. So dy by dx is y multiplying ln x plus 1, and this is what must be equal to 0 to find the stationary point. I have a product, 2 factors. This y cannot be 0 because this y is x to the power of x, and x is greater than 0. Cannot be 0. If not, if I have an equal here, it will be different, but cannot be equal to 0. So what is 0 is the other bracket, is the bracket. Yeah? So this means that ln x plus 1 is 0, which means ln x is equal to minus 1. And that means that x is e to the power of minus 1. So my x is e to the power of minus 1. And I think that's what they ask. They don't ask the coordinate. The x coordinate. So we don't have to find the y. Yeah? Be careful because usually they say the coordinates of the stationary point. Now they ask only the x. So I'm not going to waste time finding anything else. Yeah? That's the x coordinate of the stationary point. Yes? More. It says the point P alpha 2 lies on the curve. So we have a point where y is 2, this is 2, and this is the point. Yeah, so this is alpha 2. So that alpha is between 1.5 and 1.6. We enter into the numerical methods. Yeah. So remember to see that I have a root of a function in an interval. I always check the function, the value of the function in the size of the interval, and see that there is a change of sign. So if I have a function going across here, and I want to see I have a root, I check a number before, a number after, and if there is a change of sign and the function is continuous, I'm going to have a root. Yeah. In this case, my function is not going to be 0. I'm not finding a root. I'm finding this point, and in this point, the y is not 0. The y is 2. But still, I'm solving an equation. So what I want to see is when y is 2, what is x? So I know y is 2. So really what I'm solving is 2 equal x to the power of x. So if I want to find that x coordinate, that's what I'm trying to find. When y is 2, what x? what is x? Yeah, so I'm trying to solve y, which is 2, equal x to the power of x. Yeah, or if you reorganize, you are trying to find the root of x to the power of x minus 2. If you call this fx, you are trying to find the roots of that function. Yeah, that's why we are using the f of 1.5 and the f of 1.6. No, was 1.5 and 1.6? 1.5 and 1.6. Yeah, we are going to see if the sign changes. So let's going to see f of 1.5 is going to be 1.5 to the power of 1.5 minus 2. So 1.5 to the power of 1.5 minus 2 is minus 0.16. And the same with 1.6. So 1.6 to the power of 1.6 minus 2 is 0.12. So this is 1.6 to the power of 1.6 minus 2, 0.12. One is negative, one is positive, and the function is continuous. Just remember to add that line. Yeah? So change of sign, and the function continuous. There is a root. Yeah, function continuous. There is a root, which means x to the power of x is going to be equal to, yeah, that value. I know it's confusing because this is not, we are not finding the root of x to the power of x, we are finding the root of x to the power of x minus 2, yeah, because we are trying to make the y equal 2 in our equation, yeah? So when we make the y equal 2, we are solving 2 equal x to the power of x equation, yeah? Does it make sense? Yes? Okay. Okay, perfect. I don't know if I'm losing you. A possible iteration formula that could be used in an attempt to find alpha is this one. Using this formula with x1 equal 1.5, find x4 to 3 decimal places. Calculator, remember to iterate. What you are doing is you do 1.5 equal, so it's already an answer, and then you write your formula, or this bit of the formula is 2, and instead of write x, you are going to write ans, because you are going to use your previous answer. So in the calculator, what you have to type now after 1.5 is 2 times ans to the power of ans. Yeah? So 2 times ans to the power of ans. When you click equal, you're going to get, this is x1, you're going to get x2. Yeah? So B. See, when x1 is 1.5, if you click equal once, you get x.2, which is 3.674. x3, when you click equal, you get 238.55. I've done something wrong. I'm doing something wrong. So 3. Why am I getting something wrong? Are you doing with me? X3. Sorry, because it's, yeah, of course I'm doing something wrong. Look at the formula, is 1 minus xn. So I'm just typing the wrong formula, is ans to the power of 1 minus ans. Yeah, sorry. So 1.5 is the first value. Then you do 2 times ans to the power of 1 minus ans. Yeah, it was growing very, very quickly. So the first value, I hope you get the same, and you are doing with me, not just looking. 3.63299. The next one is 1.466. The next one, which is the one that they ask, is 1.6731. Are you getting the same? And we have to give that to 3 decimal places. So this one to 3 decimal places is 1.673. This one is the one that they ask. You don't need to write the others, yeah? But I just did it for you to check. Is that what you get? Are you doing with me or no? Then it says describe. Oh yeah, Priya, thank you. Describe the long-term behavior of x to the power of n. How can we describe the long-term behavior? Just clicking equal in your calculator. And if you do that a few times, you are going to see that you start to get 1, 2, 1, 2, 1, 2, 1, 2. Yeah. So this is not converging. Yeah. You have to say something like is alternating between 1 and 2. So it's not converging. Not converging. We are getting values, alternative values between 1 and 2. Yeah, explain a bit longer. I just don't want to dedicate too much time. But that's what is happening. If you click equal in the calculator more and more and more, at one point you start to get 1, 2, 1, 2, 1, 2. Yeah, so not converging. Is okay the question? We have 3 left. So we are almost done. And next one is a trigonometric question. So we have to prove this identity. In the identities, remember, and I say identity because we have the 3 lines, we are working with the left-hand side until we get the right-hand side, or with the right-hand side until we get the left-hand side, but we are not moving things right to left like in an equation. So I think it makes more sense to start with this one because we have more things to do, but not necessarily. You could start with the other if it's easier sometimes. We have 3 theta, theta, and 2 theta. So it's kind of seems complicated, but every time you have to use the addition formulae or something like that, and you have 3 theta, remember that you're going to do the same. You can do 2 theta plus theta. Yeah, so cos 3 theta is the same that cos 2 theta plus theta, and then we use the addition formula, the compound formula. Yeah, so let's going to try with that. And with these questions, there is not a single way of doing it. So usually you can work in different ways, getting the same answer, sometimes faster than others. So if I apply the addition formula to cos, is cos minus sine. Yeah, so cos, so I have cos minus, when it's a plus, it's a minus, minus sine, minus sine 2 theta sine theta. And I get always, I struggle sometimes with these questions. So I'm not always you get them straightforward. Sorry, this is the first part, and then the sine is 2 sine cos. And know what I'm saying? Sine cos sine. So sine cos cos sine. Yeah, divided by cos. We can multiply to add the fractions. So in the left-hand side, I have cos 2 theta cos squared theta, because I'm multiplying everything by cos. Yeah, so instead of writing the bracket, I'm just going to multiply straight away. Minus sine 2 theta sine theta cos theta. And then I'm going to multiply all this numerator by sine theta. So I have sine 2 theta cos theta sine theta plus cos theta sine 2 theta sine theta, and all divided by sine cos. Yeah, just adding the fractions. I can cancel what I can cancel. So I have sine 2 theta cos sine, sine 2 theta cos sine minus sine 2 theta cos sine. And then I have, this one is sine squared. So I have sine, no, not sine squared, no. So I have, what can I put together? I keep an eye on what you want. So you want to cot 2 theta. Cot 2 theta is cos 2 theta divided by sine 2 theta. And these two will be easy. So sine 2 theta is coming from here because sine to theta is 2 sine cos. So this bit is really half of sine to theta. So we have the denominator, yeah? And then numerator, let me see if I am able to find the numerator. Cosine, sorry, I changed this, the order. So this is to theta. I'm just writing twice. Sorry. Cos, cos to theta, sine theta. So when we multiply, this last bit is not correct. I have, when I multiply that by sine, I have cos to theta, sine squared theta. And now I am going to factorize these two. So I have cos to theta together. So this is equal to cos to theta multiplied by cos squared plus sine squared, which I know is 1. Yeah. So 1/2 sine to theta, and now we have it. So we have cos to theta in the numerator, because this is 1 using the identity. The 2 can go to the numerator, and here I have sine to theta, and cos divided by sine is cot, so cot to theta. Now we have it. Looking at the mark scheme, you will see that there is another way that maybe is faster, but it's more difficult to think. Yeah, that is multiplying this one first, and then thinking very quickly that is sine to 3 theta. But I don't think you would see that straight away. Yeah. Now, hence, so we are going to use what we just found. We are going to solve this equation. So look, this left-hand side is exactly the same on this one. So instead of writing this, we are going to write this, which is much simpler. That's why they say hence use that. So we have 2 cot to theta. So for B, I have 2 cot to theta equal to 4. And that's what I have to solve. And I'm going to remind you, sorry, I'm going to remind you that when you have 2 theta or a number multiplying the angle, what you're going to do is to change your interval, because if not, you're going to miss solutions, or you might miss solutions. So this interval is for theta. So what we are going to do is to transform our interval for 2 theta. So it's going to be 90 times 2, 180, theta times 2, to theta, 180 times by 2. Yeah, so this is the interval where we need to find all the solutions. So 2 cot to theta means that cot to theta is going to be 4 divided by 2, which is 2. Remember, cot is not in the calculator, so you do the reciprocal, because cot is the reciprocal of tan. So we know that tan to theta is going to be the reciprocal of that, which is 1/2. With the calculator in degrees, because we are working in degrees now, we do tan minus 1 of 1/2, and then you get that 2 theta is 26.565 degrees. Yeah, this is not in your interval. So that solution is going to help you to find the others, but it's not in the interval. So at the end, you don't want to give that solution. We are working with tan. You know, tan repeats every 180 degrees. So the next solution will be this one plus 180. And that's 206. So I'm going to actually put this here. Next solution would be plus 180 degrees, which is 206.565. The next one, 180 degrees after, will be 386, which is out of the interval. Yeah. So we have found the only solution in our interval, that is the 206 degrees. And the last thing you do is to divide by 2, but you do that after you find all the solutions, not before. Yeah. So when you divide that by 2, and we need to round, so what do I have? Sorry, 206.565 divided by 2. I don't want to lose decimals, so theta is going to be 103.2825. we have to round to something, no? To 1 decimal place. Yeah, so when we round that to 1 decimal place, is going to be 103.3 degrees to 1 decimal place. And that's my only solution. Yeah. Is it clear? Yes? No? Perfect. Any question? So this one was to prove the identity. This is a quite typical question. Prove the identity, solve the equation using the identity. And my recommendation is, even if you don't know how to prove the identity, because identities sometimes become very, very messy, and sometimes you don't find the way of proving them, do the second part of the question, because you just use the identity. You don't know how to prove it, but you can use it. Yeah, so don't skip it a bit, because usually it's easier. Okay, 2 more. Next one. A typical question of modeling with differentiation. This is if the function is a polynomial function, that is the case in most of the questions, it will be a year 12 question. Yeah? So it shouldn't be too difficult. We have a manufacturer produces a storage tank. The tank is modeled in the shape of a hollow circular cylinder closed at one end with a hemispherical shell, and the other end at the other end, shown in figure 9. Yeah, so you have like a lid at the bottom and this hemisphere at the top. The walls of the tank are assumed to have no thickness. The cylinder has radius r, height h. The sphere has radius, and they remind you that the volume of a sphere is this one, and the surface area of a sphere is that one. Yeah. The volume of the tank is 6 meters cubed. We are going to use that. Show that accordingly to the model, the surface area of the tank in meters squared is given by this formula. Typical question. You have surface area or perimeter or volume in terms of two variables, but then you need to eliminate one because you are going to differentiate. And to eliminate one, you're going to use some information that they give you. So this is very, very typical. Let's going to find the expression of the surface area in terms of the two parameters that you have. And then we are going to eliminate one. So the surface area is going to be the surface area of the hemisphere, and is once the whole sphere is going to be 4 pi r squared, which means half is going to be just 2 pi r squared. So we have that lid at the top. The surface area is going to be 2 pi r squared. Then you have the bottom lid, which is just a circle, so plus pi r squared. And then you have the cylinder surface. Yeah, remember the surface area of a cylinder is a rectangle. So if you open that, you have a rectangle. This is h, and this is the length of the circle, which means the area is going to be 2 pi r h. So plus 2 pi r h, which is 3 pi r squared plus 2 pi r h. That's the surface area. But I have the two parameters here. I have r and h, and I don't want h. Why? Because I'm going to differentiate. Yeah. How do I eliminate h? Using this information. So the volume of the tank is 6 meters cubed. So the volume, which is 6, is going to be the volume of the cylinder. So the area of the bottom, so pi r squared, times the height. That's the area, so the volume of this cylinder part. Yeah. The area of the top part, so the rest that we have here, is going, the area, not the volume, sorry, is going to be half of this, because it's just a hemisphere. I don't have the whole area, so the whole volume. So it's going to be 2/3 pi r cubed. 2/3 pi r cubed. From here, it's not a super simple question, but we are going to find h to substitute in the other. So I'm going to make h the subject. So it's going to be 6 minus 2/3 of pi r cubed. Yeah, so just from here, this goes negative, and then I'm going to divide by pi r squared. Pi r squared. I can I'm not going to simplify now. I'm going to simplify in a minute. And I'm going to go to my surface area, and I'm going to substitute the h by this expression, because that way I don't have h. And then I'm going to work with the expression until I have what I need to have. So let's do that. I have that the surface area is 3, not 2, 3 pi r squared plus 2 pi r, and I'm going to write everything that I have. So minus 6 minus 2 thirds pi r cubed divided by pi r squared. What can we cancel? We can cancel this pi and 1 r. And then we have 3 pi r squared plus, I'm going to expand the bracket. So I have 2 times this 6 and divide by this r. So 2 times 6 is 12 divided by r. And then I have 2 times minus 4 thirds. So minus 2 thirds, which is minus 4 thirds. Then this pi, and then r cubed divided by r is going to be r squared. So pi r squared. And I'm going to put together these two. So I have 12 over r plus 5 thirds of pi r squared. Yeah, which is precisely what I have to find. And that's how I've done it. I wrote the surface area in terms of r and h. I used the volume value to make h the subject and substitute and eliminate. So now my surface area is just in terms of r. That is what I want. Yeah, clear? Manufacturer needs to minimize the surface area of the tank. What are we going to do? Derivate the surface area with respect to r, because now we have one parameter, and make that equal to 0. These questions are all the same, I promise. Use calculus to find the radius of the tank for which the surface area is minimum. Yeah, they ask the radius, not the volume. Sometimes they ask you the volume straight away. So let's go to differentiate this expression of s. And if you are not able to do this part, still use it. You have the expression that you have to differentiate. Don't skip the rest of the question. Yeah. So we are going to find ds by dr, and then we are going to make that equal to 0. So I have 12 over r, which is 12r minus 1. Yeah. When I differentiate that, I have minus 12 r to the power of minus 2. I'm differentiating, not integrating. Sometimes we mix them. Minus 2. And then the second part is 5 thirds multiplied by 2. So 10 thirds pi r. 10 thirds pi r. That must be equal to 0. This one is going to be more convenient in the denominator, just to solve it. So what I'm going to do is to write that in the denominator, and then 10 thirds pi r. I think it's going to help you to see it. I'm going to multiply everything by 3 and by r squared all at the same time. So I multiply by 3r squared. So 36, I can simplify. Well, it's okay. 36, and then 10 pi r cubed, which means that r cubed is going to be 36 divided by 10 pi. 10 pi. I can divide by 2, so 18 5 pi. That means that r is the cubic root of 18 divided by 5 pi. That's the radius that gives me the minimum volume. And I would evaluate with a calculator because it's a radius, so it makes sense to have a number, a decimal number. Yeah, so 18 divided by 5 pi is 1.04, 1.005. Yeah, I'm going to round to 3 significant figures. And is meters? Meters. That's the radius that gives me the minimum value. They don't ask you in this question, but you should check that the this radius is giving you a minimum and not a maximum. That I think that should be in this question. If you look at the mark scheme, they don't do it, but I would always do it because it's 30 seconds and you are going to get the marks in case they expect you to do it. So the way of checking that, so check if that is giving us a minimum, is derivating again, which is going to be super simple always. Derivate again this expression is -2 times -12 is 24, r to the power of 1 less, plus 10/3 pi. This is going to be positive always. We don't even need to substitute. Yeah, and even if we have to substitute, it's going to be positive because they are asking us a minimum. But I would do it, yeah? So therefore, it's a minimum. And it's going to be positive always because this is positive and this is going to be positive, yeah? It's a minimum, and that's the radius. And they ask me, use calculus to find the radius to the tank. So I found that. C, calculate the minimum surface area of the tank, giving the answer to the nearest integer. So we have a formula for the surface area. That was the 12 over r plus, what? I forgot. 12 over r, 5/3 pi r squared. 5/3 pi r squared. So what we are going to do is r equal to 105, and then we are going to round. As you have this value in the calculator before rounding, I would use that one. Yeah, so don't, well, I just deleted, but use that one without rounding, just in case there is a change, and just round at the end. Yeah. Let me find that value. So you have 12 divided by that. And I get 17.21 is area, so meters squared, but they ask us to round to the nearest whole number. Yeah, so 17 meters squared to the nearest integer. And that's the minimum surface area. Yeah. Is the question clear? Yeah. Perfect. Some of you are following through all the time. So the last one is an integration question. We didn't do any integration. So use the substitution, and it's a lot of marks, so it's worth it. So use the substitution, this one, to show that this integral is this is the answer to the integral, yeah, where k is a constant. They don't ask us to find it. So let's go into integrate that. So we have integral of the h divided by 4 minus root h, the h already is written, sorry, and the change is u equal to 4 minus root h, so our denominator. Remember, when we do substitution, we will need to find the h. We need to substitute everything in the integral instead of with h, with u. For that, I'm going to derivate, so du by dh is going to be minus 1/2 of h to the power of minus 1/2, yeah, and this is h to the power of 1/2. When I derivate, the 1/2 goes to the front and it goes down by 1, which means you can write a bit better. So you have du is minus 1, and I'm going to bring back the h in the denominator and with the root symbol, the h. So the h, that's what I need to substitute, is going to be 2 root h times the u and negative. So the h, sorry, I need the h. The h is minus 2 root h du, but I can have the h in my integral. I need to substitute in terms of u. So from here, very easily, from here I can write that root h is 4 minus u, which means if I go back to my expression of the h is going to be minus 2 4 minus u du. Yeah, And now I'm ready to substitute everything. So I've kind of prepared everything to substitute in my equation. So I have dh is minus 2, 4 minus u, 4 minus u, du. That's the h. I'm just substituting the h, and my denominator is just u. I'm going to integrate this very easily. So the minus 2 can go outside, and then I have 4 divided by u minus u divided by u. Yeah, so I can integrate that very easily. Minus 2, 4 divided by u minus u divided by u, which is 1. Equal, I'm going to go here, minus 2, 4 divided by u is 4 ln u. Yeah, I ignore the 4, I put it at the front, and 1 over u is ln u. And then minus 1 is minus u. If I haven't done mistakes with the signs, yeah? And this is minus 8 ln u, but I know u, I have to go back to h. So u is 4 minus root h, so I can write that, 4 minus root h, minus u, and u is, so I have minus 2 multiplying, sorry, I have the minus 2 multiply minus u, so I have positive 2u. So positive 2u is 2, 4 minus root h plus k is the constant of integration. I should add it here as well. Plus k, so is equal to minus 8 ln 4 minus root h plus this 8 together with this k is just another constant, k prime, or it doesn't matter. It's a constant that I will have to find. The important thing are the variables. And then I have 2 root h negative. So minus 2 root h plus a constant. Call it different if you want. Yeah. And that's where we needed to find. So this is the bit that we needed. Yeah. That's the first part. Then a team of scientists is studying a species of slow-growing tree. The rate of change in height of the tree in this species is modeled by this differential equation, where h is the height in meters and t is the time measured in years after the tree is planted. Find, according to the model, the range of heights of trees in this species. This is a bit easy question when you know what you have to do, but if not, maybe you think, wow, how am I going to get the range? I don't have any information. I don't have the limits of any of the values. So I think one of the things that you can think is the height is going to be 0 or more, so it cannot be negative, for example. That's something that you can consider, like the time or a variable that cannot be negative. So you have a limit already there, it must be greater or equal than 0. And with the derivative, you can find the maximum value. So the maximum value is when the derivative is 0. So we can make that dh equal to 0. dh by dt equal to 0 means or the time is 0 at the beginning, or 4 minus root h is 0. That's going to give us the maximum value of the maximum height of the tree. So could be that 4 minus root h is 0, which means 4 is equal to root h, which means h is going to be 16 meters. So that's the maximum value of the heights of the trees, which means your h is going to be greater or equal than 0, because the height cannot be negative, and at the same time greater or smaller than 16, because that's the maximum value. Yeah, that's the way of finding the limits, because you have the derivative, you can make it equal to 0, you know the maximum or the minimum. Yeah. And then the last thing, I think, yeah, last thing it says, one of these trees is 1 meter high when it's first planted. According to the model, calculate the time this tree would take to reach a height of 12 meters, giving your answer to 3 significant figures and 7 marks. We have a differential equation. They haven't asked us to integrate it here, so we have to solve it in the last part. To have a function that relates h and t, and that's what we are going to do. To integrate this function, we are going to put the h in one side, or with h and or with t in the other. So we have dh divided by this thing, which is precisely what we integrated before. Yeah, that's why. So dh divided by 4 minus root h is going to be equal to dt, and then t 0.25 and 20. So I have t 0.25, 20 dt. I'm going to integrate. This one is already done, so don't integrate again. And this one is simpler, yeah? So we have dh divide the integral is this value here, and even if you are not able to do this first part, you can use it. So minus 8 ln 4 minus root h minus 2 root h plus k minus 2 root h plus k is going to be equal to, I can get the 20 outside, and when I integrate, it's a polynomial. It's the same as having t squared. We add the value, we increase by 1, and we divide by the new exponent. So we have t 1 plus 0.25 is 1 to 5, divided by 1 to 5, and the 20. And I could add plus k, but I already have the constant of integration here. Yeah, so it doesn't matter. It's just a number that is going to change dependent. So this is the relation between h and t. They don't really ask us to find a nice expression or an expression in a particular way, so don't overcomplicate it. They are asking you to find the height of the tree, so we just really need to substitute, but we need to find k, and the way of finding k is with this line. It says one of these trees is 1 meter high when it was planted. So when t was 0, the height was 1 meter. So we are going to substitute that here to find k, but we really don't need a nice expression, just the expression, yeah? So I have minus 8 ln 4 minus root h. When h is 1, it's just going to be 1, minus 2 root 1 plus k is going to be 0, yeah, because that's 0. So that means that k is 2 plus 8 ln 3, no, ln 3, 4 minus 1, ln 3. That's the constant of integration. With that, I am able to find anything that they ask me because I already have the expression. So this is this k here. What does it have? I need to find the time the tree, so t when h is 12. So when h is 12, find t. When h is 12, find t. So I'm going to my function here and substitute the h by 12. So I have minus 8 ln 4 minus root 12 minus 2 root 12 plus k, which is this number here, is t to the power of 1.25 divided by 20 times 1.5 is 25, no? 25. So I do this with the calculator, multiply by 25, and then I just do the root 1 over 1 over 25. Yeah, so let's see if I get the right answer. ln, I hope you are doing it with me, and if you see something wrong, you tell me. Minus 2 root 12, or a sign or something, because it's very easy to make mistakes in these questions. It's a whole paper. So I get that t to the power of 1.25 is 221.279, and then you do the root 1.25 of that value, and I get 75.154 meters, which sounds okay. I don't think I have the answer. Just checking. This one is just in case. Do you have the answer? Well, I think you will have to trust me. 75.2. Yeah. Okay. No, it's correct. It says round to three significant figures. So it's 75.2 meters to three significant figures. And that's it. That's all the paper. We have been ages here. I hope. Do you have any question? No? It's all good? Did you understand this question? Is I think it makes sense. It's just a bit scary, no? It's a lot of marks, and I don't think it's too difficult. Okay, so well done for being here. I hope you find it helpful, and I'll see you soon, hopefully. Yeah. Bye bye.